This video is over section 8.2, integration by parts. The nice thing about integration by parts is that you basically have a formula that you follow every single time. And that formula is the integral of u dv is equal to uv minus the integral of v du. Now, the thing about this formula is that you will need to identify what u and dv should be. Because if you are able to identify what u and dv are, you can find the rest. Now, choosing the correct values for u and dv are important in order to make this integration by parts method go successfully. So here are some of the guidelines. The guidelines for integration by parts are the following. When identifying what dv should be, choose the most complicated portion of the integral. However, you want that to fit a basic integration rule. So in other words, you want dv to be the more complicated part, but you want it to be easy to integrate. You also want u to be the part of the integrand that has a derivative that is something a little simpler than itself. So the last thing to note is that dv always includes dx. Now you might be thinking, holy crap, what is she talking about? I have no idea. This is way too complicated, but let me explain this by showing you an example. Here's our first example. It says, find the indefinite integral using integration by parts. Now, the reason integration by parts is nice is because this method is helpful whenever I have a product or a quotient in my integrand. So it may be helpful to rewrite this as the integral of 5x e to the negative 2x dx. Now, I've given you the formula. It might be helpful to continue to write this down each time you use it so that it's kind of engraved in your mind. Now, what we need to do is we need to figure out what dv should be and what u should be. Now, recall from the guidelines, it's helpful to choose a dv that is the more complicated part so that we can integrate it easily. So what I'm going to do is I'm going to let dv equal e to the negative 2x, and remember the dx is always included. Now, if that is dv, then whatever's left is u. So in this case, u is 5x. Once I have identified dv and u, I find v and du because those are the other parts that are required for my formula. So if dv is this, what I need to do to get to v is integrate this. If I integrate this, remember, I keep it and I divide by the derivative of the exponent. So this would be negative 1/2 e to the negative 2x. On the other hand, if I have u and I want to get du, I have to find the derivative of this. The derivative of 5x is 5 dx. Okay, so here are the steps. Step 1, identify dv and u. Step 2, Use those to find v and du. Step 3 is to plug it in to this formula. So let's do that now. Plugging this in, the integral of u, which is 5x, dv, which is e to the negative 2x dx, is equal to the following. Now just notice that what I have here is the same thing that I have rewritten. Okay, so this is equal to u, which is 5x, times v, which is negative 1/2 e to the negative 2x, minus the integral of v, which is negative 1/2 e to the negative 2x, times du, which is 5 dx. All right, now all I need to do is simplify each of these parts. Simplifying this, I end up with negative 5/2 x e to the negative 2x. Over here, I have a couple constants that I'm going to move out. So this will become a positive 5/2 times the integral of e to the negative 2x dx. All right, well, when I integrate this, I should know that this is equal to negative 1/2 e to the negative 2x because I've already done that, right? So I have negative 5/2 x e to the negative 2x plus 5/4, and that should actually be a minus because this is negative. So minus 5/4 e to the negative 2x plus c. So that answer would work. If you want to take out a GCF of negative 5/4, you can. Negative 5/4 e to the negative 2x. Then multiply that by 2x plus 1 plus c. Either of these two answers will be fine. So really, the hard part is identifying what dv and u should be. Once you have that, from those, identify v and du, plug it into the formula, and then simplify. Here is the next example. Again, it's an indefinite integral, and we want to integrate using integration by parts. And if you look at this, we have a product here. And remember, we can't just separate this and find the integral of this and the integral of that. So that's why we have integration by parts. So recall, you need to identify two things in this problem. First, you need to identify dv, and then you also need to find u. Now, in this case, you will want dv to be x to the 5th dx. You don't want dv to be the natural log portion because you're going to have to integrate this to find v, and that's pretty complicated. So if dv is x to the 5th dx, then whatever is remaining is u, so that will be natural log of 3x. So if we have identified these, we can find v. V is found by integrating this. If I integrate this, I get 1/6 x to the 6th. On the other hand, if I'm given u and I want to find du, I need to find the derivative of this. Remember, the derivative of this is found by taking 1 over the argument times the derivative of the argument. So this simplifies to 1 over x dx. I suppose there should be a dx here. All right, so now I have everything I need in order to apply this formula. So this becomes the integral of u, which is x to the 5th, times dv, which is the natural log of 3x dx. And again, this is the same thing we started with. This is equal to u times v minus the integral of v du. So now we just need to simplify this. So looking at this here, this can not be simplified any further. So this is, I'm just going to clean it up and put this in front of the natural log. Then over here, this can be cleaned up a little bit. I'm going to take this 1/6, move it out because it is a constant. And then I'll have x to the 6th times 1 over x, which simplifies to x to the 5th dx. So now I need to integrate this. And when I do, I get 1/6 x to the 6th. And then I have this plus c. So to simplify, now I just need to multiply those. And my final answer is 1/6 x to the 6th times the natural log of 3x minus 1/36 x to the 6th plus c. If you want to take out a GCF, you can, but this answer will suffice. So let's look at an example that is a little bit more complicated than some that we've already seen. So here we have the integral of 2x divided by the square root of 1 minus 6x. So let's just rewrite this so that it's a product rather than a quotient. And so this is what we want to integrate. So looking at this, I have to decide what dv should be and what u should be. In this case here, we will want dv to be the more complicated part. We do want it to be this portion here. So if dv is equal to 1 minus 6x, that quantity to the negative 1/2, then whatever is remaining is u. So u is 2x. So from here, I need to find v. When I find v, I think a u substitution might be helpful to solve this. There are a couple options to find the derivative of this. I'm sorry, the integral of this. So you can either do a u substitution or you can just apply the basic power rule, which I don't know, might be easier. So I will, if I were to integrate this, I would have 1 minus 6x. I'm going to add here. So this gives me an exponent of 1/2. I will divide by that, which is the same thing as multiplying by 2. And then I'm going to divide by the derivative of the inner function. So I will divide by a negative 6. So v is equal to negative 1/3 times the quantity 1 minus 6x to the power of 1/2. That is v. Du is a little bit easier to find. Du is simply the derivative of this with respect to x, so 2 dx. So we have v, we have du, and then we also have dv and u. So we can go ahead and plug in this information into the formula. So let's do that now. So we end up with the integral of 2x times 1 minus the quantity 6x to the 1/2 dx, so that's just what we're starting with, is equal to u, which is 2x, times v, which is all of this, negative 1/3, minus the integral of v, times du, I forgot that, so times 2 and then dx. All right, so a little bit of simplifying required. So for this, 2 times the 1/3 gives us, or a negative 2/3 x times the quantity 1 minus 6x to the 1/2 power, minus, let's simplify this a little bit. When I simplify this 2 in the 1/3 gives me a positive 2/3 on the outside, times the integral of 1 minus 6x to the 1/2 dx. Okay, so this is as simplified as possible. Now this you need to integrate. It's the same thing as what we did up here, except the sign is different on the exponent. So up here I just applied the general power rule. Down here, let me show you how to do a u substitution. So in this case, let u equal 1 minus 6x. So then du is equal to negative 6 dx. So we don't have a negative 6. We can put one in and undo it on the outside. So this here becomes, simplifying this, let's see, this is a negative 1/9 times the integral of u to the 1/2, which becomes negative 1/9 negative 1/9 times 2/3 times this quantity, and then the plus c, of course. Okay, so let's simplify this now. We can multiply this to get negative 2 over 27, I believe, times this. There are a couple different ways you can write this. You can write this as a radical. You know, a couple different ways are fine. So here is the final answer. Okay, here is another example, and same thing, integration by parts. You can see the integrand is a product, so that is a good indication that we will use integration by parts. Now this one is a little bit different because we're actually going to have to use integration by parts twice. So let's take a look at how this works. Now, if I look at this, there isn't any rewriting necessary, so I can go ahead and jump right into identifying dv and u. So you might want to pause this for a moment and see if you can identify the correct dv, the correct u, and then find their counterparts. So in this case, dv, you do want it to be the more complicated function, which is cosine of x dx. Therefore, u is x squared. If dv is cosine of x dx, then v is sine of x, because the derivative of sine of x is cosine of x. U is x squared, so that means du is 2x dx. So now we can apply this. So this is already given to us. That's the original function. So this is equal to uv minus the rest. So in this case, we have this is equal to u, which is x squared, times v, sine of x, minus the integral of v, sine of x, times du, which is 2x dx. Okay. Now looking at this, the left-hand side here does not require any simplification. It is what it is. But over here, we have something a little more complicated. Now I can rewrite this to make it a little bit easier by moving that 2 out in front. So this becomes x squared sine of x minus 2 times the integral of x, just putting the x in front of the sine of x. Now looking at this, we need to integrate this. And in order to integrate this, it is also a product, so I need to use another integration by parts. So just like before, we need to identify dv, we need to identify u. So dv is sine of x, and that means u is x. So v is negative cosine of x, and du is just 1 dx. All right, so this first part just stays as is. So let's just focus on this little piece right here. So we have x squared sine of x minus this by applying integration by parts. So integration by parts, I'm going to have this. So u times v minus the integral of v, negative cosine of x, du. All right, so I think it's helpful to ensure that whatever you just integrated is in brackets or parentheses, because you need to make sure to apply this negative to everything. So moving onward, x squared sine of x minus, cleaning this up here, if I distribute this, it ends up being plus 2x cosine of x because of the two negatives. Same type of thing here. These become a positive, and the integral of this is negative. Oh, and distribute this 2 also. Negative 2 sine of x plus c for the final answer. There you have it. The last thing worth mentioning are some common integrals using integration by parts. So this just kind of gives you a little heads up on what to let u and dv equal. If you have something of the form x to the power of n with this, this, or this, then you will want u to just be the variable, and then dv is one of those other more complicated items. Similarly, if you have the same type of thing, but natural log, arcsine, or arctangent, then you kind of want to do the opposite, and these are the cases where you will want u to be one of these. And then finally, if you have a little of both, if you have e and sine or e and cosine, then let u be the trig function. Okay, so just some things to think about. This concludes section 8.2.